This video is going to be on applications of trig functions. And specifically, we're going to talk about sine or cosine as opposed to the other ones, and that's typically what you would look at in an application problem. And what we're going to do is look at one situation and then answer several questions based off of it so we can kind of see how it works. So I know this is a lot to write, but maybe pause the video. You should write out all of it instead of shorthanding it, because these are your notes and you are going to be coming back hopefully later to look at them, or if you ever do need to come back and look at them, it will help to have the whole problem written out. So it says a population of giraffes oscillates, so it goes up and down, that's what oscillating means, between a low of 1,300 on January 1st and a high of 2,200 on July 1st. Biologists model their numbers. Biologists. So we're going to say the number of giraffes is negative 450 cos pi over 6x, well, pi over 6 times x, plus 1,750. And when we write this, January 1st is going to be where t equals 0, so that's where our graph is going to start. July would be t equals 6, because that is 6 months later after January. And so here, and actually let's not do x, let's do t. Sorry, making you erase t, and we're going to do t for time. So t equals time in months, and g is the number of giraffes. Alright, so the first question that we're going to ask in this is, what is the midline and what does it mean? And so off to the side, you could sketch this or not. A regular sine graph looks like this, and the midline for a regular sine graph would be right here at 0. So this is y equals sine. If I had a graph that had been shifted, let's say right here this is 5, then this would be y equals sine x plus 5. So the whole graph has been shifted up, and the midline of this graph would be 5. So the midline for the equation that we're talking about is 1,750, and it is basically kind of the average of the graph. I know that as we look at these, you can see that it's kind of a terrible average because none of the values are really there, but it would be the average of the graph. So we're going to say the middle or the average population. Second, we're going to say, what is the amplitude and what does it mean? So the amplitude, you can see it's in the front of the equation. So the amplitude here, remember the negative doesn't tell us anything, it just tells us that it's starting, the cos graph is starting down instead of starting up, so we don't have negative amplitudes. But 450 would be the amplitude of the graph, and that tells us how far we are varying from average, or how far we are varying from the middle. So from the middle, the 1750, you would go down 450 to get to the minimum for the population, and up 450 to get to the maximum. So we're going to say it's how many more or less giraffes than the middle or the average that there are. Next, if we look at the period of the graph, if you guys recall, to find the period, we always do 2 pi, which is a normal period for a cosine graph, which is what our equation is, divided by the value for b. So the value for b of this equation is pi 6th. So I'm going to say 2 pi divided by pi 6. That's hard for me to do in my head like that, so I'm going to do keep it, change it, flip it. The pi's cancel out, and so I just get 12. And hopefully you're looking at that like, yeah, this is monthly, and we said that January was 0 and July was 6. So it would make sense to have a period of 12 because there's 12 months. If you start at January as 0, then it's going to be 12 months before you get back to January again. So the period is 12, and this is 12 months in a year, is what it means for this problem. So it takes a year to get back to that original population value. The next thing we're going to do is sketch a graph of the function. So I'm going to go ahead and do that on this sheet. And we have our midline is at 1750. We know our low is at 1300. Our high is at 2200. So I am maybe going to go by 200 so that my graph doesn't have to be too big. So we'll go down here. 2, 4, 6, 8, 1,000. 2, 4, 6, 8, 2,000. Okay. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm actually remaking this video because I did it wrong the first time, and I'll tell you how I did that in a second. So let's also label the months down here. Alright, and then we have our low point of 1300 on January 1st. So 1,000, 1,200, 1,300. And then in July is when we get to 2,200. And the end of the cycle would be back to 1,300, so that would be the 12th month. That would be when we get back to January again. The midline is at 1750, so this is 1,800 and 1,600, so 1750 is like right in here-ish. And it is halfway between these 2 points that we hit that value. So halfway between would be right here, and halfway between would be right here. And so here is our sketch of what we would expect the population for the giraffes to be. So on this side we can go ahead and label number of giraffes. Okay, so that is our graphing a sketch. The next question we're going to look at is which 3 months have the highest population, and which 3 months have the lowest population. So we can look at the graph for this. The highest population you can see we had July, and then the 2 months before and after, or the month before and the month after that. So it'd be June, July, and August would be the highest. And then the lowest month would be, so the beginning and the end, that represents January. And then right here, this would be February, and that would be December. So it looks like January, February, December. All right. Another type of question we could ask from this is we could say, Is that the number I'm on? 6. In February, how many giraffes should there be? So in February, how many giraffes are there? And we're going to round this to the nearest whole giraffe. And so what I'm going to do in here, and we can graph this using y equals and then plug in, oh, it's from a different problem I was just doing. So you can graph it and then plug in the values that you want, or you can just plug it in right here. Now this is the part where I messed up when I did it on the previous video. I was thinking February is the second month, so I need to plug in 2. But on this graph, since we started at January as 0, then for February we're going to have to plug in 1. So let's go ahead and graph it on here. Actually, I'm just going to clear my calculator. Okay, so on here we're going to type in negative 450 cos pi divided by 6 x plus 1750. The reason I'm graphing it on here is because the next problem will need the graph. So, okay, so for my y values, or my x values, I'm going to go from 0 to 12, because that fits what I was doing right here. And then my y values, I'm going to go from like 0 to 2500. Would let me see everything. And then for February, we're going to plug in 1. All right, so if you plug in 1, we're going to say there are approximately, and I'm going to round to the nearest whole giraffe, so 1,360. 1,360 giraffes in February. And then we're also going to figure out October. So I'm going to add October as the second question. And again, October is the 10th month, but we're going to plug in 9. That was the other part I did wrong in the other video. So October is going to be 1,750. And 1,750 in October. And whenever we're doing story problems, we should always have sentence answers, just so that the person looking at the work that you did knows that you can interpret the number that you got. So we're not just saying 1,360 and I don't know what that means. We're saying we know that that means that's how many giraffes you have in February. Okay, the next question that we're going to ask is, when is the population approximately $1,500? So what we're going to do is we're going to hit the y equals button. We're going to graph y2 as 1,500. That's going to put a horizontal line on the screen at 1,500. And so we know that the population is approximately 1,500 right here, and it's approximately 1,500 right there. So second trace, intersection, and it doesn't matter where I put the cursor. It just has to be closer to one of the intersections so that I can find that. So I moved it, and then I pressed enter 3 times. And I'm getting a value for time of 1.9. So I'm going to go ahead and write this down here real quick. And then for the other one, I'm just going to move it over to the other side. Don't you guys love these awkward moments we share while we're waiting for the cursor to move? This one is 10.1 approximately. So 1.9, the 1 goes with February. So 1.9 would be the end of February. And then 10.1 would be the beginning of November. So we're going to say the population is approximately 1,500 at the end of February and the beginning of November. And if you wanted to be tricky and like use proportions and figure out exactly what day is like 9/10 of the way through February or 1/10 of the way through November, you could do that if you wanted, but this is as exact as I would like for you to have it.